Today we are going to learn about topic 3, differentiation of exponential, logarithmic, and trigonometric functions. Now, let us focus on 3.1, differentiation of exponential functions. What is an exponential function? This is the form of exponential function. We always label it as e to the power of x, or just e to the power of a function, like this. So how do we differentiate exponential functions? If we have e to the power of x only, then to differentiate it, the answer is just e to the power of x. Well, why is that the case? Usually, we have questions like this. Y equal to x squared. Now, x is the unknown and 2 is the power of x. To differentiate this, you just have to bring that power 2 to the front, copy the unknown, subtract 1 at the power, and your answer would be 2x power 1. But now, for exponential functions, the unknown is at the power. So, how do we differentiate this? To differentiate this, if it's just e to the power of x, you will get exactly the same, which is e to the power of x. But if, for example, it is not just e to the power of x, but e to the power of 2x, then when you differentiate this, what you get is, you just take that number 2 to the front and then multiply with the exponential function. How to remember this step easily? The first step is that whenever you want to differentiate exponential functions, remember to copy the function exactly as it is. And then what do we do next is just to differentiate the power and put it in front and multiply with that function. That's where the formula of this comes from. Okay? Next, if the power of e is not just x, for example, e to the power of x squared. Now, it's not just e to the power of x, but it's e to the power of x squared. How do we differentiate this? Just follow the same steps. First step is just to copy the exponential function with the power exactly as it is. After that, don't forget to differentiate the power and put it in front. Now, what you get when you differentiate x squared? When you differentiate x squared, remember you bring the power 2 to the front, multiply with the unknown, and then subtract the power with 1. 2 minus 1 is just 1. So what you get is just 2x. So that's where this formula comes from. You have to copy the exponential with the power exactly as it is, and then multiply with the derivative of the power. Now, let me do this step by step and show you from a simple example. Example 1a, y is equal to e to the power of 5x. To differentiate exponentials, remember we have to copy the exponential function exactly as it is, and then instead of writing in front of e, the derivative of the power, I want to write it behind. Okay? And what's the power? The power is 5x. So first step is just to copy the function exponential with the power exactly as it is, and then write the power inside this bracket. Okay? After that, differentiate this power. What do you get when you differentiate 5x? When you differentiate 5x, you get 5. Okay, but usually we will write all of the numbers in front of the exponential and write the exponential behind. And that's where we get our final answer. Well, if you have done enough exercises and you are getting better and faster at solving this type of questions, then you can straight away write 5e to the power 5x for the answer of this derivative. But right now, I'm showing you the steps on how to do it step by step. Let's look at question example 1b. Y is equal to e to the power of 3x squared plus 5. To find the derivative of this function, remember, we have to copy the function with the exponential and the power exactly as it is, write them down. After that, writing down d over dx with the bracket. What does this mean? This simply means that we want to differentiate the function inside that bracket. And what is the function that we want to differentiate? That is the power of the exponential, which is 3x squared plus 5. Close your parentheses. Next, I want to do this faster, so I will write down the answer of this derivative in front of exponential, because I know that at the last step I will definitely write whatever as the result of the derivative in front of the exponential. So I'm going to skip one step and straight away write the answer of the derivative in front of the exponential to save time. What is the derivative of 3x squared plus 5? You can bring this number 2 to the front, multiply with 3, you get 6, write the unknown, subtract the power with 1, 2 minus 1 is 1, when you differentiate 5 you get 0. Okay, so the answer is 6x. 6x is multiplied with the exponential function. And then this will be your final answer. 6 times x times e to the power of 3x squared plus 5. Okay, now let's look at question 1c. Y is equal to 5e to the power of 3x minus 1. Same steps follows. This is a constant. So for any derivative, whenever there's a constant multiplied with an unknown, you just have to write the constant in front and multiply with everything that's behind it. So just write 5 in front, and then remember the steps of exponential, the derivative of exponential, which is copying the exponential with the power exactly as it is. After that, multiply with d over dx and write the power in this parentheses. 3x minus 1. That means that we have to differentiate whatever that's in this parentheses. 3x minus 1, when you differentiate it, you get 3. So 3 is just a number. I'm going to write it in front together with number 5, because I know that eventually I will multiply 5 with 3. So what is the answer? 5 times 3 is 15, and multiply with e to the power of 3x minus 1. And that's your final answer. Now, let's go ahead and look at example 2. Find the derivatives of the following functions. 2a is y equal to e to the power of x plus 3 power 2. There are two ways in solving this. The first way is that this is a bracket with power 2, and since power 2 means that we have two of the same brackets, this simply means that I can expand these two brackets. And what will I get if I expand it? You have to do this very, very carefully and one by one. e to the power of x multiplied with e to the power of x means that we have the same base, and when we multiply, that means our power must be added. So x plus x is 2x. After that, e to the power of x times with 3 plus 3x. And then 3 times e to the power of x. And lastly, 3 times 3. Simplify before you differentiate. Do note that we have not yet differentiated this function. Looks like I've made a simple careless mistake here. 3 times with e to the power of x should be 3 times e to the power of x. And when you simplify this, you get 6e to the power of x plus 9. After that, since all of the operations between these terms is plus, that means we can differentiate them one by one. What do I mean by one by one? It means that we just have to apply the sum rule. Differentiate e to the power of 2x means that we have to copy the exponential and then differentiate the power. 2x, when you differentiate you get 2, and just write it in front. After that, move on to the next term, 6e to the power of x. There's a constant in front, so I'm going to copy the constant. But now, look at the exponential. This is just e to the power of x. So that means we don't have to do anything with it and just write e to the power of x. Because if we differentiate the power is just x power of 1. When we differentiate x power 1, you get 1. Next, differentiate 9, you get 0. So this will be your final answer. But you can also factorize before you end this question. What can you factorize? I can see that there is e to the power of x at both terms. And also I can see there's number 2 with 6. So that means I can factorize the smallest common factor, which is 2, and also e to the power of x. What's left is, if I factorize e to the power of x, would be e to the power of x here in the first term. And then next, behind it, what's left is just 3, because 3 times 2 is 6. And then, since I have taken out e to the power of x, so it's just 3 left there. And that's your final answer. Remember that I have mentioned earlier that there are 2 ways in solving this. So what's the other method? The other method is by using chain rule or power rule. Since I like power rule better, so I'm going to go and straight away use power rule. How to use power rule? Remember that the first step is to bring to the power and put it in front. After that, copy the function and then subtract the power with 1. Lastly, multiply with the derivative of the function inside the bracket. So, do take note that we have this term d over dx. That means we have to differentiate whatever that's in this bracket. So, copy everything in front and then differentiate whatever that's in this parentheses. E to the power of x plus 3. Remember, when you differentiate a constant, you get 0. And when you differentiate e to the power of x, it's just e to the power of x. After that, just rearrange this. Write e to the power of x in front and the rest behind. See, you got exactly the same answer as the first method. As you can see, method 2 is faster and also easier. Now, let's look at the next example, 2b. We have the function y equal to 3x plus 2 over 3x plus 2 over e to the power of x. Okay, so whenever we see a fraction, that means we can use quotient rule. And when we want to use quotient rule, that means we need to have the u and also the v. Remember the order. The expressions above should be u, and then the expressions below should be the v. After that, differentiate u and v one by one. Differentiate u, you get 3, and differentiate v prime, this is just e to the power of x, so that means you get exactly the same thing. Now, this is quotient rule. Remember what I've told you before, when you want to use quotient rule, remember the crossfish. Draw your crossfish, but remember, when this is a fraction, that means crossfish must also has fraction, minus in the middle and v squared below it. So write down the formula, write that long fraction. At the denominator, write the v and then square it. At the numerator, you have a minus sign. After that, copy the formula. Start from the tail of this fish. You start from v, e to the power of x. You go down and meet u prime, which is 3. After that, you go upwards and meet u, which is 3x plus 2. And then you go down to meet v prime, which is e to the power of x. Now, what you need to do is just to simplify. 3 power of ex minus, wait, hold on a minute. I can see that here I have e to the power of x and e to the power of x, where the sign minus is in the middle. So this means that I can factorize e to the power of x. And since I have also e to the power of x at the denominator, that means that I can cancel that factor e to the power of x. So let me factorize e power of x. So when I take it out, what's left on the left side here is just 3. And then we still have a bracket, 3x plus 2, and e power of x has been taken out. At the denominator, when we have bracket and power 2, that means that we can multiply 2 with that x. Remember these rules of indices. When we have something like this just simply means a to the power of b times c. So that means at the denominator, this is just e to the power of 2x. But since we have factorized e power of x at the numerator, we can cancel off with the e power of x at the denominator. And what's left is just e power of x power 1. Next, at the numerator, I can open the parentheses. And at the denominator, it's just e power of x. 3 minus 2 at the numerator is 1 minus 3x over e power of x. And that's our final answer. Now, let's take a look at example 3. Example 3a is just e power of 3x plus 2. So remember the steps, which is, the first one is to copy the exponential exactly as it is and then differentiate the power of the exponential. And then writing the number or the derivative in front of that exponential. Look at the next example, 3b. this is y equal to 3e to the power of 3x plus e power of x over e power of x. Now, should we solve this by using quotient rule, like in example 2b before? Or should we just do it with a different way? What exactly? Well, for this example, there's a better way in solving. Since there's a plus in the middle, and then this is a fraction, and I can see that all of the terms is e, has the same base, which is e, even though it has the different powers. But this means that I can simplify them further if I can split this into two fractions. Like this. E power of 3x over e power of x plus with e power of x divided with e power of x. Then I can simplify this to be 1. E power of 3x divided with e power of x. This simply means that when we divide, then the power will be subtracted with each other. So it's just e power of 2x. But remember that by now we have not yet differentiated, we have just simplified the function. So how to differentiate it? Just differentiate it term by term. How do you differentiate e power of 2x? Just differentiate the power. You get 2, and then copy the exponential exactly as it is. Differentiate 1, you get 0. And that's your final answer. That's all for today. Thank you for watching.